So this is the first example of nomenclature. I have expanded the structure. As per rules, will count in this direction. IUPAC name will be 4-bromo 2,2-dimethyl hexane 246 4-bromo 2,2-dimethyl hexane. And as far as classification is concerned, this will be secondary alkyl halide. Secondary alkyl halide. Second example. CH3 CHCl CH3 CHCl, again CH3 within brackets, it goes like this. Then CH2 twice. CH2 twice will be CH2 CH2. Then CCl2 CCl2, and at the end it is C2H5, again CH2 CH3. 1, 2, 3, 4, 5, 6, 7 carbon atoms. Wait a minute. CH3 CHCl CH3, and yes. Now, on the basis of lowest locant rule, will count in this direction. This will be 2,5,5 trichloro, I'll repeat, 2,5,5 trichloro 2-methyl heptane, and will not be able to classify on the basis of primary, secondary, tertiary, because there are more than one halogen atoms present. More than one halogen present, therefore we cannot classify. Now coming to fill in the blanks. As I told you earlier as well, fill in the blanks will be the most important part of organic chemistry. To solve fill in the blanks, you should open your register in front of you, refer to these notes as much as possible. You have to apply these reactions, because when you apply these reactions, then only you'll be able to memorize. Otherwise, it will not be possible for you to memorize these reactions. There'll be many more reactions coming in future. So first sequence is propene plus HCl. Most of the time, I'll not be writing hydrogen just to save time. So on the basis of Markovnikov's rule, we'll get 2-chloropropane. One thing more, when I'm explaining here, in case you're not able to find any reaction in your notes, you can ask me. I'll wait for you and tell you, please search on that page, you'll find this reaction. Now, this 2-chloropropane is reacted with aqueous NaOH. This is the very first nucleophilic substitution reaction in your register. Halogen will be replaced by OH. So answer B is 2-propanol. Now, although this is 2-propanol, but in general, this is alcohol, right? Now, alcohol reacts with C to give D. C to give D plus POCl3 and HCl. These byproducts given at the end, POCl3 and HCl, these give you the hint what is the answer for C and D. Because these two byproducts you will not find anywhere in any other reaction. These two byproducts will find when alcohol is reacted with PCl5. This is alcohol, this is PCl5, and answer D is chlorine at the same position as OH. The answer is 2-chloropropane. Second sequence. And gradually these fill in the blanks, and all assignments will gradually become difficult. Second, isopropyl alcohol. Isopropyl alcohol is nothing but 2-propanol. Reacted with KBr sulfuric acid. KBr and sulfuric acid is nothing but in situ preparation of HBr. So think as if you are reacting 2-propanol with HBr. So when you react with HBr, product is 2-bromopropane. 2-bromopropane is reacted with B to give 2-nitropropane. Again, in nucleophilic substitution reactions, you'll find one reaction in which halogen is replaced by NO2, and that will be AgNO2. So answer for B is AgNO2, silver nitride. Remember, if you use KNO2, product is not this, product is RONO. Alkyl nitrite is obtained, not nitroalkane. Third sequence. Ethanol plus HCl zinc chloride. This very first reaction is Gross method. In Gross method, OH is replaced by chlorine. So we get chloroethane. Chloroethane is reacted with B to give ethyl methyl ether. This is ethyl, this is methyl, this is ether. This is ethyl methyl ether. In this product, this chain comes from here. It means this part comes from B. This is CH3O. This is CH3ONe. This is Williamson synthesis. You can check in your notes. This is Williamson synthesis. Although we can use alcohol also, CH3OH, but avoid that because in your notes you'll find that reaction with alcohol is a slow reaction. That is why to speed up the reaction, we use Williamson synthesis in which sodium salt of alcohol, sodium alkoxide, is used. Next question. Next is what, explain why. They're all ABCD labeled. It means you'll find in your notes. In case you're not able to find, you can always ask me. Next, what happens when sodium acetate is reacted with iodoethane? Sodium acetate, CH3COONa, is reacted with iodoethane. Sodium and iodine will form sodium iodide. This is NSR, right? Sodium will be replaced by ethyl. So write that so-and-so is reacted with so-and-so leads to the formation of sweet smelling ester. As I told you earlier, and what happens when, apart from writing the chemical equation, balance equation, you have to write something in words also. If there is a name of the reaction, mention that. If there is any particular property of the product, mention that. Like in this case, sweet smelling ester is obtained. Second, iodoethane is reacted with NaOH solution. I've not read the question completely. Iodoethane is reacted with aqueous NaOH. NSR takes place to give ethanol and NaI. Now further it says, and products treated with AgNO3 solution. Remember, if the question is, and the product is reacted with, product means will consider only the organic product. But this question says products. It means both these products, mixture of these products is treated with silver nitrate solution. Silver nitrate will not react with alcohol. This will remain as such. Sodium iodide and AgNO3. If you remember, you have performed silver nitrate tests for chloride, bromide, and iodide in the lab, right? It's the same thing. This will give AgI plus NaNO3. And silver iodide will be yellow precipitates. Now listen carefully. So we'll say when these are reacted, NSR takes place to give ethanol and NAI, which on further reaction with AgNO3 give yellow precipitates of AgI. There's no need to mention about others in the sentence. Mention about that which has a special property and yellow precipitates of silver iodide. Now, listen one thing more about this particular what happens when. Let us say question remains the same and we have chloroethane. Chloroethane with NaOH will give ethanol and NaCl. NaCl with AgNO3 will give AgCl, and AgCl will be obtained in the form of white precipitates. White precipitates. Now, what is the importance? Why did I tell you? Let us say the question is, how will you distinguish between iodoethane and chloroethane? To distinguish between them, react both the compounds with aqueous NaOH. After that, treat products in both the cases with AgNO3 solution. In one case, you'll get yellow precipitates. In the other case, you'll get white precipitates. That's how you'll be able to distinguish between pair of compounds. You'll come across many distinguishing tests in future in your syllabus. Next question. How will you convert? First conversion is very simple. I'm not even writing on the board. Aniline into iodobenzene, convert aniline into diazonium salt. Then diazonium salt is reacted with aqueous NaI or Ki to give final product. We are taking up second one. Ethanol into fluoroethane. Ethanol into fluoroethane. Wait a minute. There are many ways, many methods to convert ethanol into chloroethane. One of them is PCl5. Reaction with PCl5 will lead to the formation of chloroethane, or you can use other methods. You can use SOCl2 pyridine. You can use the Gross method, HCl zinc chloride. That is your choice. But whichever reaction you use, you have to write all proper reaction conditions. This to be converted to fluoro, you can use Schwarz reaction. AgF, heat. You'll get the final product. Next question. Out of bromide and iodide, which is a better nucleophile and why? See, that nucleophile is better who can easily donate its lone pair of electrons. And that nucleophile out of these two will donate lone pair easily whose electronegativity is lower. So in this case, answer is iodide is a better nucleophile because its electronegativity is lower and therefore donation of LP is easy. Out of ethane and bromoethane, which compound has higher boiling point and why? It is bromoethane. Reason is number one, higher molecular weight. Second reason, more surface area and therefore stronger van der Waals forces. Next question. Give chemical equations for the preparation of following compounds by NSR. First, we have to prepare 2-propanol. You just listen carefully because I'll not be writing all the reactants. 2-propanol by NSR. Reactant should be 2-halopropane plus aqueous NaOH. 2-halopropane plus aqueous NaOH. Second, propane nitrile. One carbon will come from KCN. So this should be haloethane plus potassium cyanide or sodium cyanide. Next is 1, 2, 3, 4, 3-iodopentane. This you can prepare by Finkelstein's reaction. 2-chloro or 2-bromopentane with Ki acetone. Finkelstein's reaction. Next, 1-butene. sodium salt of alkyne with haloethane. You'll get this final product. Ethyl nitrite, haloethane plus KNO2. Nitropropane, halopropane plus AgNO2. Then this is ester. Let me draw the structure. C6H5, CH2. This is C6H5, CH2, O, COCH3. If you remember, I told you in the ester, that chain which is attached to oxygen comes from alkyl halide. It means this comes from alkyl halide. It should be one reactant is benzyl halide and the other is sodium or silver salt of acetic acid. Last, this is thioether. And to prepare this, we can this is symmetrical thioether. Moreover, you can use 2 molecules of haloethane and sodium sulfide. Sodium sulfide. So that's how we'll prepare them.